Grignard reagents, represented as R mg/X, are powerful tools in organic chemistry. Because magnesium is less electronegative than carbon, the R group carries a partial negative charge, making it a strong nucleophile and a strong base. The carbonyl group is highly polarized. The more electronegative oxygen pulls electron density away from the carbon, leaving the carbon atom electrophilic and ready to be attacked by a nucleophile. In the first step of the reaction, the nucleophilic R group from the Grignard reagent attacks the electrophilic carbonyl carbon. This is the rate-determining step where a new carbon-carbon bond is formed. As the new bond forms, the carbon-oxygen pi bond breaks. The electrons move onto the oxygen atom, and the central carbon changes its geometry from trigonal planar sp2 to tetrahedral sp3. This results in an intermediate known as a magnesium alkoxide salt. The negatively charged oxygen is stabilized by the positively charged magnesium halide complex in the anhydrous ether solvent. The type of alcohol produced depends on the starting carbonyl. When a Grignard reagent reacts with formaldehyde, which has two hydrogens attached to the carbonyl, the result is always a primary alcohol. If we use any other aldehyde, the presence of one existing alkyl group means the final product will be a secondary alcohol, containing two carbon attachments to the hydroxyl-bearing carbon. Reacting a Grignard reagent with a keton, which already has two alkyl groups, creates a highly substituted tertiary alcohol. This is a primary method for building complex carbon skeletons. The second stage of the reaction is the acidic workup. We add dilute acid to protonate the alkoxide oxygen, converting it into a neutral hydroxyl group to finish the alcohol synthesis. It is critical that these reactions are performed in anhydrous conditions. Grignard reagents are such strong bases that they will react instantly with water or alcohols to form alkanes, destroying the reagent. Looking at the energy profile, the nucleophilic attack is the highest energy barrier. The formation of the stable CC bond makes this an overall exothermic process, releasing energy as the alcohol product is formed. In summary, Grignard reagents add to carbonyls to form new carbon-carbon bonds, yielding primary, secondary, or tertiary alcohols after an acidic workup. This concludes our lesson. Generated by Vision Solve AI.